Hello everyone. Today we are going to explore one of the most beautiful and surprising formulas in all of mathematics, Binet Formula for Fibonacci numbers. I can tell the impossible formula because it does something that seems absolutely impossible. It uses irrational number to generate exact integers. How can a formula containing a square root and irrational constants always produce integer numbers? By the end of this presentation, you will understand exactly how this magic works, and you will appreciate why this formula is considered one of the most elegant results in mathematics. Let's to investigate it. Here is paradox that makes this formula so fascinating. The impossible question. Fibonacci sequence, Binet formula. How can a formula with a square root of 5 always produce integers? You know the Fibonacci sequence. The definition of the Fibonacci sequence for f0 is equal to 0 and f1 equals to 1. fn equals to fn minus 1 plus fn minus 2. Each number is the sum of two previous numbers. The problem: to find f100, we should count in 99 numbers. No direct formula. For centuries, mathematicians thought so. So, here is Fibonacci's numbers: 0, 1, 1, 2, 3, 5, 8, 13, 21, and 34. So, how we should calculate f100? For f100, we should compute 99 steps and calculate the previous sentences. In 1843, Binet, Jacob Philippe Marie Binet, discovered formula. The formula is fn equals to phi n minus psi to the n of an square root of phi. 5. Where phi equals to 1 plus square root of phi over 2 and psi equals to 1 minus square root of 5 over 2. So we know the phi and psi and also square root of phi approximately equals to 2.23 How can irrationals produce integers? This is a question the mice read. The phi approximately equal to 1.618. Also, it's irrational number, and psi approximately equal to minus 0.618. Also, it's irrational, and square root of 5 also irrational. Here, fn is always an integer. This is mathematical magic. We have a system that the inputs are irrational, but the output is integer. Here is the process. How the calculation, how the process receive the irrational and generate the integer outputs. Let's calculate f3. f3 for n equals to 3. f3 equals to phi to the 3 minus psi to the 3 over square root of 5. Phi to the 3 in step 2. Expand the powers. Phi to the 3 equals to 1 plus square root of 5 over 2 to the 3 equals to 16 plus 8 multiplied square root of 5 over 8 equals to 2 plus square root of 5. And psi to the 3 equals to 1 minus square root of 5 over 2 to the 3. After the simplification, we have the psi to the 3 equals to 16 minus 8 multiplied square root of 5 over 8 equals to 2 minus square root of 5. So, after the simplification, f3 equals to 2 plus square root of 5 minus 2 minus square root of 5 over square root of 5 equals to 2 multiplied square root of 5 over square root of 5. The square root of 5 cancel each other, so the final result is 2. F3 equals to 2. How square root of 5 disappears? The magic is the cancellation. The general pattern for any n, we have the phi to the n equals to a n plus b, and this n multiply square root of 5 over 2 to the n, and psi to the n equals to a n minus b n multiply square root of 5 over 2 to the n, where a n and b n are integers. So the square root of 5 term always cancel. So here we have phi n, as we have phi n minus psi n equals to 2b multiply square root of 5 over 2 to the n. And yeah, the square root of 5 cancel each other, so the result is integer. Also, the study has a secret. Why psi to the n become negligible? Because the value of psi approximated, the value of 5 approximately equals to 1.618, and the value of psi approximately equal to minus 0.618. The absolute value of psi is less than 1 for large n. For example, here we have psi to the 10 approximated to 0.008, and psi to the 20 approximately equal to 1.00007, and psi to the 50 approximated equal to 10 to the minus 11, and psi to the 100 approximately equals to 10 to the minus 20. So for large value of n, the psi n become negligible and close to the zero. Here is the curve of the psi n. When n is large, so n close to the zero. For large n, fn approximately equals to nearest integer to the phi to the n over square root of 5. So, Binet formula in action, we can use F5 for 5 Fibonacci terms. Number F5 equals to 5 minus psi to the 5 over square root of 5. Phi to the 5 equals to 11 minus 5 multiplied square root of 5 over 2. And so F5 equal to 5 multiply square root of 5 over square root of 5 equals to 5. And also F8, 8 Fibonacci number, equals to phi to the 8 minus psi to the 8 over square root of 5. Phi to the 8 equals to 47 plus 21 multiplied square root of 5 over 2. And psi to the 8 equals to 47 minus 21 multiplied square root of 5 over 2. So, and if 8 equals to 21 multiplied square root of 5 over the square root of 5 equal to 21. And so, the result of a Binet formula always is an integer number. Here we can, by finding the F100, we can use the direct calculation using the Binet formula. F100 equals to phi to the 100 minus psi to the 100 all square root of 5. So psi to the 100 approximately equals to 10 to the minus 20. So F100 approximately equals to phi to the 100 is over square root of 5. So after rounding, the nearest integer is equal to F100. Here we have F100. is a big integer number with 21 digits. Binet Formula gives us direct access to any Fibonacci number. Here also we have the history of the formula. Who discovered it? Jacob Sleepy-Marie Binet, a French mathematician, published in 1843. And Leonhard Euler also knew this formula earlier, around 1765, 100 years before Binet knew about that formulas. So, although there is a law that statistical law, no discovery is named after its origin of discovered. So the discovery of the formula has named by the Binet formula. Also, it has a connection with the golden ratio. We know that the ratio of Fn plus 1 over Fn when n goes to infinity equals to phi, and we know that the phi approximates equals to this value 1.618 and so on. Binet insight, Fn is essentially equals to phi to the n of f square root of phi. The Fibonacci sequence is just power of golden ratio. So we know that the relation of the golden ratio with the Fibonacci numbers. Here also is the different number of Fibonacci number. We know that the strong golden is strong. And final, we have the summary of the presentation, the direct formula to calculate the Fibonacci number that Fn equals to phi to the n minus psi to the n, or n square root of phi. The main paradox was related to the irrational input, integer output, and because the square root of 5 terms cancel each other. And the big idea, direct mathematics has deep root in the continuous mathematics or irrationals. So here, the main idea of this presentation is relation between the integer and irrational number. That how can the integer can generate irrational number or irrational number generate the integer numbers. Actually, mathematics is full of beautiful surprises. The impossible formula that works perfectly. Thanks for watching. If you enjoyed the presentation, please like, comment, and subscribe. See you in next video.